Hi, I'm Charles Dillard with Amphenol Broadband Solutions, and welcome to our Fiber 101 Training Series. In this training, we will discuss Remote PHY. As we go through this training, the chat will be open, so if you have any questions, put those in the questions section, and we will address those at the end of the training. With that, let's get started. In this training, we will define Remote PHY and the benefits of it, as well as gather an understanding of distributed access architecture. Cable operators have done a great job of upgrading their networks by replacing long cascades of amplifiers with a hybrid fiber coax network. What we're showing here is an analog fiber link from the head end to the node. And in this example, there are 500 customers connected to that node. This is a node plus 4 architecture. Even with this architecture, there are some challenges. The data feed from the head end must be shared with all of the subscribers in this particular node. So we must closely monitor utilization to make sure that we are not selling a service that we cannot support. Another drawback to this architecture is the noise generated by the analog fiber link, as well as the cascades of amplifiers. In order to offer higher data rates, then we must use a higher modulation, whether it's 512 QAM or 4096. For these higher order of modulations to work, the signal to noise must be improved. Also, the combined noise in the upstream from each of those 500 homes generates a large portion of the upstream noise. One way to overcome these challenges is by doing node splits. We reduce the number of homes per node, and there are less users sharing the data. Here we're looking at a node plus 0 architecture. The amplified cascades have been eliminated, just reducing the noise. But we still have noise from the analog fiber link. And by splitting the nodes, we create more service groups. And this means there's more CMTSs, which means more powering and more space in the head end. And extra CMTSs cost money. This is where distributed access architecture, or DAA, comes into play. With this architecture, the MAC and the physical layer are moved from the CMTS out into the head end. With Remote PHY, the physical layer is moved from the head end, or CMTS, out into the field. With Remote MAC plus PHY, both layers are moved from the CMTS or head end out into the field. So when we talk about the physical and MAC layer, we're talking about portions of the OSI model. This model illustrates how data is moved from one portion of the network to another. Layer 1 is simply wiring, fiber, network cards, or anything that helps two network devices communicate. With Remote PHY, RF line cards are replaced with digital line cards, and they have Ethernet ports. Modulators and demodulator functions of the CMTS is now placed out into the field. This removes all RF cabling, splitting, and combining from the head end. An Ethernet switch is installed to provide a 10 gig fiber link. Digital fiber equipment is less noisy, less expensive, and have an extended range when compared to analog fiber links. At the node location, fiber transmitters and receivers are digital, which means they convert the digital signal to analog so they can be sent to the amplifiers. Remote PHY devices have fiber loop-through ports that allows one Remote PHY node fiber to feed additional Remote PHY nodes, which helps save on fiber counts. Many existing fiber nodes can be fitted with Remote PHY components, typically in the lid of the node. The Remote PHY devices uses digital fiber transmitters and receivers and creates the RF digital carriers. The addition of the Remote PHY device does increase the power draw of the node. It's been estimated that the power increase will be around 25 to 30%. This additional power cost will still be less than the savings in the power cost at the head end. The Remote PHY device also generates additional heat that may be a challenge to dissipate. One solution is to have the Remote PHY device in its own housing. The digital RF output is then connected to the amplifiers. This allows for the reuse of existing amplifiers. Some benefits of Remote PHY include higher SNR, reduced RF ports, reduced CMTSs, reduced cooling, rack, and powering in the head end. Digital optics is less expensive and more reliable when compared to analog fiber links. They have a further reach, and no laser clipping occurs on the return. Remote PHY can also be used to reduce the number of CMTSs when doing node splits. The CMTS's RF line cards are replaced with digital line cards and connected to 10 gig Ethernet switches. So instead of purchasing more expensive CMTSs, you can purchase less expensive Remote PHY shelves. Another component of distributed access architecture is Remote MAC plus PHY. With this architecture, the MAC and physical layers are moved out into the field. Remote MAC plus PHY devices are installed in the field just like remote PHY devices. In the head end, the CMTS is now a router. Finally, when doing node splits, powering needs to be considered. Prior to doing node splits, all of the powering for the nodes and the amplifiers all share the same coaxial cable. After node splits, some of these devices may now need a dedicated path for powering. And since remote PHY devices require additional powering, more power supplies may be needed. In summary, we define remote PHY and the many benefits of remote PHY, as well as gain a better understanding of distributed access architecture. Now I need to move over to my desk and open up the chat to see what questions we have. In the meantime, if you have additional questions, feel free to put those in as well. Okay, so I made it to the chat, and let's see if we have any questions related to the training. And we do. So we have a question from Aaron, and let's see, what is that question? Does remote PHY affect the way maintenance tech troubleshoot? So like I mentioned a few minutes ago, the beauty of remote PHY is that now we're able to push fiber deeper and deeper into the network. And with remote PHY is that we're actually taking some of the communication portion and pushing it out there as well. So with the physical layer where the modulation and demodulation occurs, that will now occur, like I mentioned, at the device itself, the remote PHY device, instead of the head end. As a result of that, a technician, a maintenance technician or system technician, where they would normally call into the head end to see, how's this channel is doing in the head end, so they have a way of troubleshooting. Well, now that channel will be created out in the field. So, there's different testing that will have to occur as a result of that. A lot of it is going to be more of a new mindset of where, signal is being originated. And then also, when you are having issues with it, what is the escalation path? Because as we start to get into remote PHY plus MAC and then virtualization, the CMTS at that point could be anywhere. So how a maintenance tech troubleshoot as a result of remote PHY will change, but it'll get easier once they start to understand what are the things that they're looking for and the new testing that's going to be required in order to be able to troubleshoot. But great question. Another question from Victor: what are some of the other parameters that we need to check for outside of MER and BER? So as a maintenance technician or anyone that's going to be maintaining the network, we're familiar with how to check RF, MER, and BER, but we need to be familiar with other parameters, especially since we're going to be dealing with like layer 2 tunneling, et cetera. And then because now with a digital fiber link and an Ethernet switch, in the hub side or head end, now we need to understand Ethernet and Ethernet testing. So currently, if you're in a system where you have enterprise technicians who go out to businesses and install like fiber internet access circuits, well, they are familiar with some of the RFC testings, such as the 2544. So now those type of testing will need to be leveraged by other individuals, such as maintenance technician as well. So they still need to understand MER and BER, et cetera. But having an understanding of like layer 2 Ethernet testing, and that goes into training as well, is that if you have enterprise related training, like I mentioned, that's training that the maintenance technician or a system technician can leverage in order to get a better understanding of the technology, and then also the inner working of remote PHY and pushing that layer 1 and layer 2 out into the field. Also understanding of pseudo wires. with leveraging an IP network to push out different types of services from one end to the other. So again, BER, MER still will be important, but also understanding Ethernet testing will help get maintenance technicians up to speed on some of the different testing required for remote PHY. And let's, yeah. And the next question, what is the biggest benefit of Remote PHY Plus Mac? Great question. With Remote PHY Plus Mac, we're not only pushing the physical layer out to the device out in the field, but also layer two, the Mac layer. So if I step back a bit, with deploying remote PHY only, we're pushing, the physical layer, which is that modulation, demodulation, or just creating the signal. But if we only deploy that and leave layer two in the head end, layer two handles the timing associated with devices at a subscriber's house. If you take cable modems, they rely on TDMA in order to have like time slots in order to communicate back to the head end. So that way, one modem is not communicating at the same time as two or three other ones. So if we leave the MAC layer in the head end and only deploy remote PHY, then for longer runs, we may have issues with timing, and those timing can cause errors out in the field. But by deploying both physical and the Mac layer with remote Mac plus PHY, then you reduce the issues of timing and errors out in the field. Another great question. So, will sweeping of the network stay the same? And so, when it comes to sweeping, and not only sweeping, but also status monitoring and leakage, currently, prior to remote PHY, we have these RF test ports, in the hub or the head end, and we leverage those RF test port in order to, use for like sweeping, leakage tagging, status monitoring. So I will answer that question, with a question, which is, as we start to deploy remote PHY, we need to, take a look at, what are the questions that we should be asking before we deploy it. Will the meters, need to be replaced that we use for sweeping currently? And probably the obvious answer would be no. So there needs to be a way that a technician can still sweep with their meter without us having to put more hardware into the hub site or head end. So if that's the case, then chances are it will be more software based. But there are stuff that we currently do that can help with sweeping, such as using a PNM to get the measurements and telemetries of some of the parameters that we currently have out there, like ICFR, et cetera. And then that way we can use PNM to identify what nodes do we need to pay more attention to, instead of just having a plan of just sweeping every node. Also, outside of that is an option would be like leveraging sweepless sweep, and in order to be able to still do a true sweep of the network with remote PHY. But more often than not, operators are looking to where we don't want to change the way maintenance techs are currently sweeping out in the network. So, what do we have to do on our devices, our signal level meters, in order to do that? Vendors are working on, what does that look like with a software-based upgrade to their meters, since we don't have those RF ports in the hub site or head end that we're currently using. And let's see, there's another question. What are the difference with remote PHY nodes compared to standard HFC? Um, the good thing about with the remote PHY upgrade is that a lot of vendors have the ability to actually put in modules into the case itself instead of having to cut out a new piece of equipment. Uh, the main difference with it is that understanding that now at that optical node is that the actual signal is now being created at that point. And then, like I mentioned earlier, understanding that testing would be a little different. You no longer have the luxury of being at optical node, and you have light levels, and then you call into the head end, or hub site to verify that a channel is there. Because with remote PHY, a technician could run into an issue with there are channels that are missing. And then, especially when we go full blown a virtualized network, uh, understanding in your area what's the escalation path. If I am having an issue with channels missing, the out of band carrier, not enabled. So with that, just understanding that when you're at an optical node now with the remote PHY node, those are questions that you have to keep in mind that you traditionally didn't have to worry about with a standard HFC optical node. What can we expect as a good SNR improvement? So, great question. Because with remote PHY, we'll be replacing that analog fiber link with a digital link. Uh, so what that means is if your signal creation, the RF, is being created closer to the subscriber, then that's going to help with that SNR issue that we currently have to deal with. Depending on what you read or who you talk to, SNR could improve anywhere from 7 to 8 SNR compared to using an analog fiber link. And let's see if there's any more questions. What kind of training will need to take place for maintenance technician with the rollout of remote PHY? Like I mentioned, understanding layer 2 IP, TCP/IP over DOCSIS, understanding pseudo wires and uh, you know just Ethernet testing in general. Like I mentioned, currently, we have dedicated technicians such as enterprise technicians that deal with like circuit turn up. So they're familiar with the RFC testing and checking for jitter, latency, etc. Taking the time to go through that type of training and documentation. And again, most operators, if they're doing any type of fiber internet access with businesses today, chances are they already have that training content anyway. So again, getting used to understanding layer 2 from that OSI model. So again, it shouldn't be a huge hurdle because content already exists today. But just understanding that now that technology is now in their world as a maintenance tech. Even if you think about um, you know 10 years ago with fiber, the only people that ever touched fiber were maintenance technicians, or if you had contractors that you leveraged to install fiber or troubleshoot fibers or fiber restoration. But with fiber to the home, we pushed out fiber deeper and deeper into the network. As a result of that, we had to train hundreds and thousands of technicians who never touch fiber. They predominantly work from the tap to the customer's house. So with fiber to the home deployment, we had to introduce, a different segment of our company to fiber. Same thing with Remote PHY. Now maintenance technicians who may not have to deal with like RFC testing and understanding Ethernet the same way that a enterprise technician does. Now they're being introduced to Ethernet in their world. So as we deploy fiber deeper into the network, there's going to be this, I guess, a where technologies and job roles and understanding of technology is going to start to mix a little bit, uh, and which is a great thing to have. And again, especially when we get to like no plus zero, we start to do stuff like full duplex and understanding, what does that mean and what do we have to have on our network in order to be able to uh, do like full duplex on our network. So a lot of exciting things as a result of pushing out fiber deeper and deeper into the network, and Remote PHY will allow us to do that. So another great question. And let's see if there are any others. Are there any additional concerns associated with Remote PHY? So as a result of pushing complicated technologies and layers of the OSI model out into the network. One thing we have to be concerned with is tampering of this equipment. You may have heard of like machine or man in the middle, cyber attacks. Uh, because we're actually originating the signal out in the field now. So we have to be mindful of access to that those layers out in the field. Also, not only just like tampering of it, is that understanding, and this kind of goes back to the question about the difference with a HFC node and a Remote PHY node, is that because it's going to be software based and there's going to have to be firmware updates, is that when that node goes down, it can take anywhere up to 5 minutes to reboot. So, when we're thinking about the quality of service for our customers and downtime of those services, it's going to be a lot different than our traditional HFC node. So, again, understanding that it's software based, there's going to be some firmware updates that needs to happen, and how do we do that? Because they're going to be strategically out in the field. So, can we do that remotely? If there's an issue to where it doesn't take place, how do we get that firmware updated? And knowing that the boot cycle for it is, anywhere up to 5 minutes. These are things that we just need to be conscious of as we look to deploy Remote PHY. Also, with the deployment, it's not something to where, you're going to come in on a Monday and the plan is to change out every optical node to a Remote PHY device. Some operators may choose to do it with greenfield. So as we are deploying fiber to a new location, to go ahead and put Remote PHY in instead of just going out there and replacing their current HFC nodes, which is really what this training was more geared to. Is that understanding what Remote PHY is and the benefits of it, such as improved SNR, being able to collapse hub sites and headends and the RF combining inside of the headends and hub site. But then also understanding, what are some things that we need to be conscious of, in order to, get, faster services, new technology out there, because there's always a trade-off, with technology. So you know, that's what this training was about. More of the get you to start, asking questions of what does it look like when we start to deploy it, and then engaging with the appropriate people in your company, the engineers, the managers of of maintenance, as well as developing an escalation path. So when it's time to troubleshoot, after you've had all the training and you got up to speed on, Ethernet and layer two, etc. Defining an escalation path so that way, when there is an issue with a remote PHY device out in the field, how do you quickly get that, resolved so that it's not impacting to our customers. And let's see if there's any more questions. Okay, so look like that's all the questions. Again, I want to thank you for attending this this session of Fiber 101 Remote PHY. We are looking to do more sessions for fiber. So if you have any ideas, or if you wanted to see some of the previous training sessions, like a part two to it, reach out to myself at Amphenol Broadband Solution, and you can reach me at cdillard@abs-go, and bring your suggestions, your recommendation over to us. With that, I want to thank you for attending. And again, Remote PHY is going to do a lot of great things for our industry. It's not as scary as we once, may have thought it was. But just like anything, uh, finding, a way to adjust for escalations before they happen. Understanding, what training or up training we need for our technicians and engineers in the field, just like we do with any other advancement in technology. So again, looking forward to more of these type of training, and I will see you next time.